Hello friends, in this video we are going to study about the temperature measurement device known as radiation pyrometers. Here we will study its principle of working, construction, the types of radiation pyrometers, its advantages, disadvantages along with its applications. So let us start with our topic. Radiation pyrometers are the devices which are used for the measurement of very high temperatures. Other devices which are used for temperature measurements are like thermocouple, thermistor, resistant temperature detector, that is RTD. So they can also be used for the measurement of temperature, but for very high temperature measurement we cannot use these devices because at such a high temperature these devices can get damaged. So for high temperature we have to develop some other device, or we have to use some other device, and for that purpose the pyrometers are used. Now in industries and plants, there are some situations where we have to measure the temperature of very hot liquids or corrosive liquids. Means the liquids which are in the boiling condition, or the liquids or the chemicals which can corrode the instruments. Okay, so corrosive liquids and hot liquids. So for their temperature measurement, the thermocouples, RTDs and thermistors, they cannot be used because they can get damaged because when they come in contact of the hot and boiling liquids and the chemicals, the instrument get damaged. So for that purpose radiation pyrometers can be used. Also, the among the RTD, thermistor and thermocouple, we know that the highest temperature measuring range is for the thermocouple. Means for lower temperature ranges, we use thermistor, then RTD, and then thermocouple. Now, if we want to measure the temperature which are above the range of the thermocouples, so for such temperature measurements, the radiation pyrometers are used. Also, if the object whose temperature we want to measure is a moving object, then for those cases also radiation pyrometers are used. So we can say that all those situations where the basic temperature measuring devices or common temperature measuring devices like thermocouple, thermistors and RTDs cannot be used, for those cases radiation pyrometers are used. Now let's come to the principle of working of the radiation pyrometers, that how they measure the temperature of an object. Now, whenever an object is heated, it is going to radiate or emit some type of energy. Okay, some amount of heat or energy is being emitted by an object whenever it is heated, and that concept is used by the radiation pyrometers. The radiation pyrometers, they measure the energy or the heat emitted or reflected by a hot object. So radiation pyrometers, they work on the principle of measuring the thermal radiations produced by a hot object. So the object whose temperature we want to measure, because that is kept at a very high temperature, so that object is going to emit or reflect some amount of heat. Okay, and it is going to generate the radiations, and these radiations which are generated due to temperature are known as the thermal radiations. Now these thermal radiations, they are a type of electromagnetic radiations, and these radiations fall in the electromagnetic spectrum. So these thermal radiations which are emitted due to the temperature or due to that hot object, they are a type of electromagnetic radiation. Now these electromagnetic radiation, they will be having a particular wavelength in the range from 0.1 to 100 micrometer. So these thermal radiations are having the wavelength in the range from 0.1 to 100 micrometers. Now the practical radiation pyrometers, they should be sensitive to all the wavelengths, that is from 0.1 to 100 micrometer. But these ideally the radiation pyrometers should be sensitive to all this range, but the practical radiation pyrometers, they are sensitive to a limited band of wavelength. So we have known that every hot object is going to radiate the energy, and it is going to generate the thermal radiations, and these thermal radiations are going to have a particular wavelength. Now this radiation pyrometers, the total thermal radiations which are emitted by a hot body, they are given this total radiation. The amount of this total radiation is defined by the Stephen Boltzmann law, and this law says that so every object is going to radiate the energy. So the total radiation which is emitted by a body, it is given by this law, QB equals to sigma T raised to the power 4, where T is the temperature, sigma is the Stephen Boltzmann constant, and QB is the total radiations. So it is watts per meter square. So this much amount of heat is being radiated by the object. Sigma was Stephen Boltzmann constant, and the value of this is 57.2 into 10 raised to the power minus 9 watts per meter square degrees Kelvin. Then T is the absolute temperature in degrees Kelvin. Okay. and QB was the total energy radiated. Now from this equation you can see that this total radiation, it is proportional to the temperature. Okay, so as we increase the temperature of the hot object, or its temperature is being changing, the radiation emitted by the body is also changing. Okay, so as the temperature increases, the radiations also increases, and because these radiations are having a particular wavelength, so wavelength is also changing. So by measuring the total radiation, we can have an idea or an indication about the temperature of that object. And this principle is being used by the radiation pyrometers. So this Stephen Boltzmann law shows that the radiations are proportional to the temperature, or they are a function of temperature. Okay, so the heat radiated by the object is a function of the temperature, and this principle is being used by the radiation pyrometers for its operation or for the measurement of temperature. Now, as I have said that the radiations, they are going to have a particular wavelength. So based on this principle, there are two types of radiation pyrometers. The first type is the total radiation pyrometer, and second type is the selective or partial radiation pyrometer. So there are two types of radiation pyrometers: total radiation pyrometer and selective or partial radiation pyrometer. The difference in these two types is that the total radiation pyrometer is going to measure the total amount of radiations emitted by the object, whereas the selective or partial radiation pyrometer, they are going to measure the radiation of a particular wavelength or of a selected band. Okay, so that is the difference. Here the total amount of radiation is being measured, and here only the selected part is being measured, that is partial radiation measurement is done. Whereas in the selective, so in total radiation, total emitted heat is measured, whereas in selective partial radiation, the selected wavelength or the given wavelength, at that particular wavelength the radiations are measured, or we can say partial radiations radiated from the hot source are measured. Now let's come to the construction of the radiation pyrometers, that how the radiation pyrometers work and what are the main parts or main components of it. So for that, first of all, we will see the block diagram of radiation pyrometer. So this is the block diagram of the radiation pyrometer. You can see the main parts are the hot object which is radiating the energy or the heat. Here we are having the lens which is going to collect all these radiations and concentrate them on a mirror. Now this mirror, again we are having a lens here and then the adjustable eyepiece. So the observer is going to observe these radiations. It can observe and adjust them so that all the radiations are being captured here and they can be measured. Okay. Now these radiations, with the help of this detector is going to detect these radiations and convert them into a suitable output level or output voltage, and that voltage is being used to measure the temperature. Means output voltage will be proportional to the temperature, and here on the temperature display we will get the direct reading of the temperature. Okay. So this was the construction or block diagram. Let's see its working. So you can see that in the radiation pyrometers, the main parts are the lenses and the mirrors which are used to collect the heat radiated by the object. So we can say that radiation pyrometer is an optical system which includes a lens, mirror and an adjustable eyepiece. Okay, so these are the parts of the optical system or the radiation pyrometer. Now the heat which is radiated by the object now, because the object is very hot, so it is going to radiate the energy or emit some amount of energy, and this heat radiated or emitted from the hot body, it is passed on to the optical lens which collects it and is focused onto the detector. So this objective lens is going to collect all the radiations and it is going to focus it on the, with the help of this mirror, it is going to focus all the radiation towards this detector. Now this detector, it can be a thermistor or it can be a photomultiplier tube. Okay, because these devices are used as the detector because they are having a very fast response time. So this gives radiation pyrometer also a very fast response time, and the detector, as soon as it gets all the energy radiated by the object, it is going to give the output. So by the detector, the heat energy is converted into its corresponding electrical signal, and this electrical signal is then sent out to the temperature display unit where the temperature reading is being displayed. So this was the basic radiation pyrometer, that how it measures the total heat radiated by the object and converted into temperature and how it gives us the temperature readings. First, the energy is being collected by the lens and then it is given to a detector. Then detector converted into a corresponding electrical signal, and that electrical signal is given as an output, or that electrical signal is proportional to the temperature of the object. Okay. So that was the working of the radiation pyrometers. Now comes its advantages and disadvantages. The first advantage of radiation pyrometer is that it can be used to measure very high temperature without coming in contact with that hot object. Now, another advantage is that in the block diagram you have seen that we have used an objective lens to focus or collect all the heat energy radiated. Now, this objective lens, it can be adjusted to measure the temperature of different ranges, like the objects which are of very small in size, their temperature can also be measured by adjusting the focus or the focal length of this objective lens. So objects which are very small in their size, like even 1 by 15 inch in diameter, their temperature can also be measured with the help of radiation pyrometers, because the objective lens which is being used in here, or the optical lens, this lens can be adjusted, its focal length, the focus can be adjusted, so that if the object is kept at a very far distance, that their energy can also be collected by the lens. So that is an advantage of radiation pyrometer. Now, because this radiation pyrometer, it is an optical system where lenses and mirrors are used, so the sight path of the device is maintained by the construction of the instrument components. So the sight path means that how much area it can cover, or the distance between the hot object and the device, that sight path is maintained by the construction of the instrument. That what kind of instruments, what is the focal length of the lenses and the mirrors, so according to that the sight path can be maintained. Okay. Now, another advantage of the radiation pyrometers is that because the radiation pyrometers, it can measure the temperature of very high object without coming in contact of it. So like if we want to measure the temperature of corrosive liquids also, in that case also it is very helpful. Another advantages of the radiation pyrometer is that it gives a very high output signal, moderate cost and fast response. Okay. So these are some of the advantages of the radiation pyrometer. Now comes its disadvantages. There are very few disadvantages of radiation pyrometer. First is its non-linear scale. As we have seen the Stephen Boltzmann's law that QB is proportional to T raised to the power 4. So here a non-linear relationship is there because it's proportional to T raised to the power 4. Okay. So it's the scale is non-linear, that is a disadvantage. Also, errors can occur in it. Due to the environmental conditions and due to there are many factors due to which the errors can occur in the radiation pyrometers. So that is also a disadvantage. Also emissivity. Of the target material can affect the temperature measurements. Emissivity is also a factor for the hot objects, so that is going to affect the temperature measurements. So these were the advantages and disadvantages. Now we come to its applications. We have already seen some of the applications of radiation pyrometer, that it is used for the measurement of very high temperatures. It is used for the measurement of temperature range which is above the range of the thermocouples. Also for the corrosive liquids and hot and boiling vapors and liquids. For that also the radiation pyrometers can be used. Also for those objects which are very rapidly moving, so for those temperature measurements also radiation pyrometers are used. So for moving objects, hot moving objects which are rapidly moving, then high temperature measurements above the range of thermocouple, the temperature measurements for the target where physical contact is not possible, like the corrosive and boiling liquids and vapors. And it is also used to measure the invisible rays from the radiations. So these are the applications of the radiation pyrometer. So in this video, we studied about the temperature measurement device, radiation pyrometer, which is used for the measurement of very high temperatures where the device cannot be in the physical contact with the object. Here we studied its principle of working, its construction, block diagram, types of radiation pyrometer, along with its advantages, disadvantages and applications. So I hope that this topic is now clear to you. Thank you.